the creator of Redis, the database running behind Twitter, GitHub, and half the internet, just built a fully functional hardware emulator without writing a single line of code. Salvatore Sanfilippo, known online as Antirez, used Claude Code to generate a Z80 and ZX Spectrum emulator from scratch, and it passed every single test in ZXAll, one of the most brutal CPU test suites ever written. That happened the same week Andrei Karpathy declared that coding agents basically didn't work before December, and basically work now, and Mitchell Hashimoto revealed he runs background AI agents on Ghosty while he's away from his desk. Programming is changing fast, and the people reshaping it aren't theorists. They're veteran builders shipping real software. Salvatore Sanfilippo is one of the most respected systems programmers alive. He created Redis, the in-memory data store used by millions of applications worldwide. When he talks about software, people listen, and what he just did got the entire developer community talking. Antirez built ZOT, a Z80 CPU emulator, a ZX Spectrum 48K emulator, and a CP/Sank 2.2 operating system emulator, using Claude Code with zero handwritten code, not AI-assisted, 0 lines written by a human. The Z80 was a legendary 8-bit processor from 1976 that powered the ZX Spectrum, early arcade machines, and the Game Boy. Emulating it correctly means replicating hundreds of instructions, obscure flag behaviors, and undocumented silicon quirks that trip up even experienced emulator developers. To validate accuracy, Antirez ran his emulator against ZXAll, Frank Kringle's exhaustive Z80 test suite that systematically checks every instruction against all flag combinations, including undocumented X and Y flags. ZXAll is the gold standard. Passing it means your emulator behaves like real Z80 silicon. ZOT passed at 100%. The process itself is remarkable. Claude Code worked for roughly 20 to 30 minutes total, and produced about 1,200 lines of clean, well-commented C code. The agent was prompted 0 times during implementation. It worked entirely alone. It implemented instruction groups incrementally, wrote integration tests, debugged with printf calls and memory dumps, and fixed its own bugs. Antirez described the process as very similar to how a human programmer would approach it. Critically, Antirez used a clean room methodology. He collected Z80 specifications first, then started a fresh Claude Code session with no internet access. This prevented the model from copying existing emulator implementations. To verify, he later ran both Claude Code and OpenAI's Codex against major open-source Z80 emulators to check for code theft. Neither found any evidence. The implementation was genuinely novel, distinct from every other Z80 emulator out there. The final ZX Spectrum emulator is about 3,500 lines of C across 4 files. The CP/Sank M emulator adds another 2,000 lines. No dependencies beyond the standard library. For the past 2 years, skeptics have had a reliable talking point. AI can generate boilerplate, sure, but it can't handle real complexity. It can scaffold a to-do app but chokes on anything requiring deep technical knowledge, precise specification compliance, or subtle debugging. ZOT demolishes that argument. A CPU emulator isn't a CRUD app. The Z80 has 696 opcodes when you count undocumented instructions. Flag behavior varies per instruction in non-obvious ways. Passing ZXAll requires getting all of it right, every edge case, every bit. And the person validating this result isn't a YouTuber building a weekend project. Antirez built Redis. His credibility on what constitutes production-grade system software is about as high as it gets. The clean room approach matters just as much as the result. By cutting off internet access and feeding only specifications, Antirez proved the model wasn't regurgitating memorized code from GitHub. It was reading specs, reasoning about instruction semantics, and assembling a working implementation from first principles. That's engineering, performed by a machine, directed by a human who never touched the keyboard. This also reframes what vibe coding means at the expert level. Antirez didn't just prompt and pray. He designed the methodology, chose the validation criteria, and verified the output. The human expertise was in architecture and judgment, not syntax. Watch for whether Antirez's clean room methodology gets adopted more broadly. If specification-driven AI development can produce ZXAll passing emulators, the same pattern could work for protocol implementations, codec development, and hardware drivers, anywhere a formal spec exists. The question shifts from can AI write correct code to can you define correctness precisely enough for the AI to target it. Antirez's ZOT emulator is a single dramatic proof point. But what does AI-assisted development look like as a daily practice, not a one-off experiment, but a sustained workflow used every single day on a real product? That's exactly what two of the biggest names in the developer world addressed this week. Andrej Karpathy, former director of AI at Tesla, co-founder of OpenAI, and one of the most influential voices in machine learning, posted this week that programming has changed more in the last 2 months than in decades. His exact words, "Coding agents basically didn't work before December, and basically work since." Karpathy's personal numbers back it up. In November 2025, he was writing about 80% of his code manually with 20% agent assistance. By December those numbers had flipped, 80% agent, 20% manual. In just weeks, he attributed the shift to a rapid succession of model releases in December, Opus 4.5, Gemini 3, and GPT 5.2 all landed within days of each other, each bringing improvements in coherence and what Karpathy calls tenacity, the ability to power through large multi-step tasks without losing the thread. As a concrete example, he described giving an agent a dense prompt to log into a server, set up SSH keys, install VLLM, download and benchmark a model, build a web dashboard, test everything, and write a markdown report. The agent worked for 30 minutes, hit multiple problems, researched solutions online, resolved them independently, and delivered the finished report. 3 months ago, that would have been a weekend project for a skilled developer. Karpathy has even retired his own terminology. He coined vibe coding last year. 3 weeks ago, he replaced it with agent tech engineering, emphasizing that you're not writing code 99% of the time. You're orchestrating agents and providing oversight. Meanwhile, Mitchell Hashimoto, co-founder of HashiCorp, creator of Vagrant, Terraform and now the terminal emulator Ghosty, shared his evolved daily workflow in detail. Hashimoto blocks the last 30 minutes of every working day to kick off background AI agents. While he's away from his desk, agents work on research, edge case analysis, and generating pull requests. He estimates agents run 10 to 20% of his working day, and he's actively trying to increase that number. The acceptance rate on agent-generated PRs is 10 to 20%. Hashimoto doesn't trust AI output blindly. He curates aggressively. But even at that low acceptance rate, he gains meaningful extra productivity as a single maintainer of a complex open-source project. He sometimes runs multiple checkouts of Ghosty simultaneously. Ghosty, Ghosty 2, Ghosty 3, Ghosty 4, with different models competing on the same task. He pulls the best parts from each. Simon Willison, the Django co-creator and prolific AI commentator, reinforced this shift with a new chapter in his Agentic Engineering Patterns Guide. His advice: hoard things you know how to do. The more working solutions you've collected over your career, code snippets, proof of concepts, blog posts documenting techniques, the more powerful your inputs become when directing agents. Your past experience becomes training data for your AI workflow. The significance here is the convergence of 3 independent, highly credible practitioners, all saying the same thing at the same time. Karpathy, Hashimoto and Willison don't work together. They build different things in different domains. But they've all arrived at the same conclusion. The daily act of programming has fundamentally changed, and it happened fast. Hashimoto's workflow is particularly instructive because it's honest about the failure rate. A 10 to 20% acceptance rate means 80 to 90% of what the agents produce gets thrown away. That sounds terrible until you realize the agent work happens during time. The developer literally isn't at their computer. The marginal cost of those failed attempts is close to zero. Even a small yield from off-hours agent runs is pure upside for a solo maintainer. This is where the maker movement comparison falls apart. A Hacker News discussion this week asked whether vibe coding will fizzle out the way 3D printing hype did around 2015. The difference is that 3D printers never changed what experienced machinists did every day. AI coding agents are changing what Karpathy, Hashimoto and Willison, 3 of the most skilled developers on the planet, do every day. When the tools change elite workflows, not just hobbyist experiments, the shift is structural. But the Stanford data point matters too. Software job postings for junior developers are down 16%. The irony is that Hashimoto's workflow and Willison's hoard what you know advice both depend on decades of accumulated expertise. You need deep knowledge to curate at a 10 to 20% acceptance rate. You need a library of working solutions to feed agents useful context. The tools amplify experience. They don't replace it. The key metric to track is Hashimoto's 10 to 20% number. What fraction of his working day agents are running in the background? He said he wants to push it higher. If acceptance rates improve with better models and better prompting patterns, a single developer's effective output could scale dramatically. Watch for whether Ghosty's development velocity visibly accelerates as a one-person project competing with larger teams. That would be the clearest real-world signal that this workflow actually compounds. 6 months ago, the question was whether AI could write code at all. Now the question is whether experienced developers who refuse to adopt agent workflows can keep up with those who do. That's a very different conversation, and it's moving faster than anyone predicted. If you want to stay current on how AI is reshaping software development, subscribe. We cover this space every day. See you in the next one.